Hello and welcome to session 8 of our Python learnings. We are going to cover modules today, and we are also going to cover Python environment, virtual environment, specifically what in the world is virtual environment in context of Python, and why is it important, and why is it of value, what it can do for us, how do we set it up, and so on and so forth. So again, a quick introduction to what we're running through right now and where we operating and how to get started if you're hopping on the first time. Just a quick overview. So we are at iligatfree.github.io/python-learn-marathon. It's a bit of a long name. I put it into link in the YouTube recordings for every one of the recordings I do for the session. So you would be running off of this website. You can see the Twitch stream there that you're watching right now. I have it paused for obvious reasons. The learning channel recordings are on the YouTube channel in a playlist that you can find in the link right now. Today we're going to be going through session 8, which is our modules: debugging, Python path, and virtual environments. I do have notes for this one. It's relatively extensive and it's kind of hopping around and we're making files and things like that. So the notes are available on the website, and I'm literally going to be running this lesson off of these notes. So that would be a useful one to dive into. The next thing we have here, sorry for a lot of scrolling. So if you haven't run this before, you would do run on Replit. This is the environment that we're using. If you haven't run it before, you would click on that button and it would spin up this environment for you. So this is our session 8. So we have gone through a number of things here to make this happen. But let's look at the actual basic setup of this. So we're going to be in modules.py. Right, that's going to be kind of our base file, and then we're actually going to create a folder and move a Python file in there to explore how modules work. So to make sure that you're running this modules.py, what we need to do, since we're running in Replit, we go to .replit file, which is our configuration for Replit, and instead of Python functions, we're going to put in Python modules.py. Right, so let's run it real quick. It's going to come up empty as we expect it to, because there's nothing in the modules folder. The whole notion of modules and why we're covering them and what it's all about. Right, once your code becomes complex enough, you want to arrange it in certain manner where you don't have one huge file, but you build out your functionality in separate files and you're able to link to it, right? As a developer, I'm sure you've seen it in your native language, how it is all done. So what we're going to cover today is actually how it is done explicitly in Python. How does the Python actually find the modules? How do we structure modules of our own, and how we do all of that work? So let's take a look at just building out a basic function that we can then use as kind of our union that will move around across different entities and move it into different files and play with it. So we're going to come back to our favorite rock, paper, scissors game. I don't know if it's favorite for anyone else but me. But anyway, so we're going to do a very tiny module of it. And that is going to be our, essentially our NPC, right? Non-player character. That's going to be our PC move that we're going to implement here. So what we're going to do, we're going to go and let's put together choices that we're going to be picking from. So it's going to be choices equals to list of them, and it's going to be rock, paper, scissors, right? So we're grabbing that. As you know, we're going to be using function choice from our random library. So we're going to do, so we ironically are importing a module from a default library in order to actually do this work here. So if we go from random import choice, and the next thing that we're going to do, we're going to create the function PCMove, right? The one that kind of with basics of the functions that we looked at in previous sessions. So we're going to define, we're going to call it PCMove. And we're going to, I can type, I'm serious. PCMove, we don't have any inputs for it, right? It's just an output function. And all it's going to do is going to return choice out of choices. Let's see here. Do I have it all right? Yes, I think I have it all correct. It's just highlighting is a bit off. So let's just run it to make sure that everything is fine, right? We don't have anything that we're calling yet, so we don't expect anything particular to happen here. So next thing we're going to explore is we're going to explore an entry point, right? So we have in multitude of languages, we have kind of an execution entry point. In Python, it's a little bit interesting that out of the gate, because you put a script together, if you actually put a line, as you know, into a Python file, like that would print something, would produce some kind of output or read some kind of input or what have you, it would just execute when you would execute the script, right? So there isn't a mandated convention for our, public static void main of any type within Python. However, Python does have a convention of an entry point for a module and an entry point for the entire application. We're going to be just looking for an entry point for a module right now. So the way we would sort out if we need to execute an entry point is by doing running an if statement, and we're going to be checking it if dunder name equal dunder main. You might have heard a weird word I just used, and once I'll finish typing, I will explain what in the world that means. So let's go result equals to PCMove. What am I doing here? Sorry, PC underscore move, open close parenthesis, and then we're going to print f PC move was result, close double quote outside. All right, so we have this thing, we're gonna run it, we're gonna see what it does. PCMove was rock, and then we run it multiple times. As we know, random works for us, so it does what it needs to do. Okay, so let's take a look at what in the world we did here. So there are special variables that do exist in Python, and we will be exploring a good number of them. And one of those special variables is dunder name. So dunder name tells us which module this is. So interestingly enough, we'll take a look at dunder name once we actually build out additional modules to see what it stands up for. The deal is, however, by convention, when you run a particular module directly, which is our modules.py, right? So we run Python modules.py. So when we execute a particular module as an entry point, it by default internally has a variable dunder name that is equal to dunder main. So dunder, the reason it's called dunder is because it is preceded by two underscores, double underscore, hence dunder. So you would actually hear rather frequently in Python a term dunder. That's what it means. It's actually within lore and within convention, and it is a term you would hear. So anyway, so we have this relatively straightforward and relatively robust setup here that just does what we would expect it to do. So the interesting thing here is that it's nothing particularly special, but we have we have this if statement here that right now is just okay. So we're running that module, right? If we did not have this if statements and just ran line 17 and 18, without indentation, obviously, we would have gotten the same result. So, okay, it's nothing particularly significant right now, aside from this check. So let's take a look um, let's take a look at the following. Let's take a look at the notion of Python path and virtual environments. Kind of step away from this thing. We kind of build our piece to get us going forward, but let's take a look at a few things, and then we'll come back to it and we'll modify it and reuse it for variety of other experimentations. So what we're going to do right now is something that we haven't done directly, just specifically so that we could record things, but we're going to run directly in Python REPL. So let's go to the right side of this window, right? So as you remember, the right side of this window in REPL, it is actually our Linux console. So we can literally run like LSL, that's the simplest check I like to run, and that gives us entire folder structure here of everything we have, right? So our modules.py is in here. So what we're going to do, we're going to launch Python REPL, which is going to be console taking us direct, executing the Python commands directly. So all we're going to do, we're going to type in Python. Type in Python, hit enter. So we're running Python 3.8.5 in this environment. So what we're going to do, we are going to explore the following. We're going to explore modules, and we're going to explore paths that everything is coming from. So the first thing we're going to do, we're going to import sys, which is a system module that is default Python module. So we're going to run import on that, and we're going to run sys.path. So path is a global variable within that module. As you see with Replit, whenever you type in a variable of some sort and hit enter, it is actually going to spit out a content of that variable for you, which is very convenient for debugging and exploration of various kinds. So what we have here is we have a list of folders. And this is the list of folders that Python explores when it looks for modules you have requested. So in this case, when we're importing sys, the sys module is coming from one of these folders. So first one is, double quote, the empty one. That is the local folder that you're running in. So Python will always, and first of all, look for modules within your local folder that you're running this module from. That's going to be the first one. The next one is you got your Python 3lib, Python 3.8 side packages. You got your userlib Python 3.8.zip. So there's a compressed folder that allows you to pull some modules from it. You got your userlib Python 3.8 and userlib Python 3.8 lib din load. So dynamic load. So the deal is like depending on environments and the various setups, you might end up with different paths for those packages, which is all great and cool. The deal is, however, you take on these various projects and you end up with varieties of modules that you end up using, and like you need libraries for some but not for the other. You need to be able to package them for one project but not for the other. So how do you handle that? So the first thing that we're going to do, we're going to do the following. We're going to actually, before we explore paths a little bit deeper, let's take a look at our modules.py that we created, right? We actually can import it here and see what's happening there. So what we're going to do, we're going to do import modules. That ends up being kind of silly, right? We named this thing modules.py. So the way we can actually retrieve it is by running import modules. So what we do is we call the specific file by its name because it is located in the same path. We don't need to do modules.py, we just do import modules. So we hit enter on that. The next thing that we can look at, we can do modules.choices. So let's take a look at choices, right? This is our choices. So this is the list of items that I created for us to play with in the function. So we can, when we import the module, it's kind of expected that we essentially have modules.choices is going to give us that global variable that we declared within that module that contains all those values, right? So we can do modules.choice function call, And if we run it, oh yeah, it ends up being, no, it's not choice. My apologies. It's not going to be choice. It's going to be PC move. So that's another interesting thing to see, PC move. So that was a happy accident, as someone would say, specifically Bob Ross. But so when we run modules PC move, right, um, we have the we can actually execute the function, right? That's kind of normal. That's kind of expected. The interesting thing, however, when I did this module choice, right, what in the world happened there? Instead of saying, I don't know what you're asking for, it told me require positional argument sequence. So what I'm going to do here is I'm going to do a single, let's just do 1, 2, 3. We're going to put a list in there. So I'm just going to, let me zoom in real quick. So I'm going to put a list in here, and then I can run it, and I can see that it gives me one of the choices. So what happened here is we have imported choice from random into modules file. At that point, modules.py, not modules.py, but imported module named modules has a function that choice, because it imports it from elsewhere, so that name is available from within the module. It's very important actually for the next section that we're going to be where we're going to be exploring testing. We're not going to be exploring mocking in there, but that is part of the reason, that is part of the way how mocking is done, is the fact that you have that function. Not only does it exist in a different library, but when you import it into a particular module, it is available in that particular module by calling that particular module dot name of the function or name of the variable. So enough of that kind of madness and excitement. So let's jump out of the console right now. Let's just do exit. Yeah, and just wanted to, again, do a quick overview. So we have with our paths, because we're going to be jumping into virtual environment, let's pay attention to our paths. We have empty, we have this, Python 3 site packages, we have Python 3.8 zip, Python 3.8, right? So it's all either our local folder or it is an environment in which everything is running. So let's do the next thing. What we're going to do next, we are going to create a virtual environment. So virtual environment is a way to wrap all your libraries, all the packages that are needed. So you might be familiar, if you're familiar with Node, you have a notion of site packages, and that kind of by default creates a folder for you locally right within your project, and it does that whole pushing all these site packages there, and kind of organizing that whole for you. Python doesn't do that by default, but Python allows you to create virtual environments. There are also a lot of different modules and a lot of different setups that allow you to manage Python environments. But for this specific packaging and for pathing and things of that nature, we're just going to use straight up VN that comes with Python. So the way we're going to run it, we're going to run the following command. We're going to run Python -m. That would indicate that we need to execute the following script. I'll need to look up honestly what -m means because I don't remember it off the top of my head. Then we're going to run venv, which is our virtual environment module that creates virtual environments. And then we're going to do .env. So .env is a choice for our folder that we want to create in the local environment. So let's run that. It's going to kind of silently churn for a little bit, and then it's going to come back with nothing, basically a thumbs up. So let's do ls-l. I probably should have shown what was, because it's dot, it's a hidden folder, so ls-auxl. So now we see our hidden paths. So now we see our .env folder that has been created. Okay, so let's zoom out because we can explore files on the left side here. So we got that .env folder. So .env folder has our include our bin. So bin would have a link to Python that we would be currently running, and variety of other Python relevant executables when it creates. So when a virtual environment is created, it actually provides a local shortcuts to Python that is being used for this project. So if you happen to have various versions of Python installed, you potentially can have those linked through the virtual environment to the setup. And there are systems that are considerably more complex that actually allow you to manage multiple instances of Python and so on and so forth. But this is kind of the basic Python setup. And then your includes that we don't have anything special in here right now because we didn't install any packages. And you have your libs side packages. That's where all the madness would go. So this is a virtual environment that got set up for us within this folder. You could it's a convention to have a .env or .venv, and actually some IDs would automatically pick up on that, and if you have one of those folders in, the ID would actually hop on and use that virtual environment for debugging and executing by default. So we kind of took a look at venv. So one of the so let's take a look. So right now, even though we have created a virtual environment, we have not loaded it, right? So let's take a look at the following. We're going to take a look at list of the libraries that are available to global Python for us. So the way we look at it, we're gonna use command pip, right? That's our, remember we have used it. Come on, zoom in. We have used it for Python installer, not Python installer, package installer, right? When we pull some packages in. So here we are going to just do pip freeze. So pip freeze allows us to get a list of packages that we have currently installed by default into global Python. You see this plethora of things, right? We have it's just when they spin up Python environment, this is all that's available here. We don't really need any of this, but this is amazing, right? We have like pluggy, pillow, we have Pygame, so we can build games in this, PyOpenGL, all kinds of wonderful stuff. None of it we really need for the projects we're dealing with. So I mean, while it's not a big deal, but it's basically not necessarily useful in here. So the next thing we're going to the other thing that let's take a look at which Python we're actually running, right? So that would give us the path to Python we are running. So if we run that, we got our apt virtual env Python 03 bin Python, right? So that's where our Python is located in that path. So we have all these kind of things that are global environment pointing everywhere within the environment around here. So we want to now really kind of say, we don't want to deploy new packages into global environment. We don't want it to go into anything and everything. We want to localize everything to virtual environment. So the way we would go about it, we have, if you remember so I'm going to do lsl.env/bin. So we're going to list the content of bin, and we see here, excuse me, the script called activate. So the script called activate is what is going to launch our environment. As you see, it's created for different shells. So we're just going to use the plain activate script. The way you use it, you don't run it within. So we're talking about running it with Linux and Mac OS. When you do it in Windows, it's relatively similar. The only thing is you're running PS1 instead of running activate. But within Linux and Mac OS, you would run a source command, and then you would do .env, which is our subfolder that we chose, right? .bin /bin /activate, and you can tab complete that, and then hit enter. So what had happened now is that you got your .env in parentheses prior to your console, and that would appear in any environment really. That means that your virtual environment got activated. So let's take a look at pip freeze now. Right, so pip freeze should be considerably more modest. It's not considerably more modest for some reason. The virtual environment still contains a ton of different modules that it is showing. Okay, yeah, that's. I was expecting the list to be considerably shorter, to be honest. So anyways, let's take a look at which Python we're running here. So Python that we're running here, you see that one did oblige, and so we're looking at a considerably shorter list. Not shorter list, but a different path here, right? We have home runner Python learning marathon -5. That's apparently the folder I'm running in. .nv bin Python. So it is referencing a shortcut, or rather a link in the subfolder as opposed to referencing the global one. So I'm honestly not certain why pip freeze showed all the global packages, including the smaller ones. This might have been modification in this environment specifically. When I was showing it prior, it was a little bit more kind of pruned. Let's take a look, however, at our Python path, right? So the way we would explore Python path, again, let's go to run Python console. So we're gonna drop into that, right? We're still running the same Python, it's just running it through a different set of links. Let's do import sys like we did prior. So we're importing that sys module, and then we're just going to show sys.path to show what we have available. So now, if you look at it, we have a little bit of a different set available. So we still have local one available. We have the virtual env, zip, all those available. However, we also have this additional folder available here, which is our home runner Python learn marathon 5.env Python 3.8 side packages. So it is going to be looking at the global packages that are available. Hence, pip freeze showed us all this wonderful stuff. However, at the same time, it is also going to be looking for locally installed packages. So whenever we would install packages locally, which we will do in the next section here shortly, we are going to actually have that installed in our local, in our local subset. So you see that that particular folder got added to our virtual environment. So anything that we would install would end up dropping there. All right, so let's type in exit. I'm going to zoom out a little bit. Take a quick breather. I don't have water with me, so that's not good. Take a quick breather. Next thing we're going to look at is debugging. So with IDE that we have, you normally have capability to debug and test various steps through and kind of see how it works, right? I believe this IDE is no exception. Trying to remember how. I think you can just put a breakpoint in here, or maybe just if we run debugger, right? Oh yeah, we have a little nuance here. We cannot play with debugger in here because we're in project mode. So when you're in Replit in project mode, you actually cannot do the debugger. But normally you are able to drop a breakpoint in if you just trying things out and just writing pure Python, and you can actually run debugger in here and step through like you normally would with any other IDE. However, Python has this wonderful capability to actually allow you to do debugging in Replit and command line. It's obviously not the only way to debug Python, right? You can debug it like you would normally do in IDE, but you can also debug Python inline with everything else. And so the way you do it, there are a variety of Python debuggers. The one that I tend to use for local debugging is called IPDB, which is Interactive Python Debugger. So what we're going to do in order to actually get a hold of Interactive Python Debugger, so we know this thing has Poetry, which is a system that's capable of checking your imports and bringing people installing necessary imports and running it the way you would like to run it. But we're going to right now do the importing by hand. So we're going to use pip to import our IPDB. So let's do that. We're gonna go pip install IPDB, and by default IPDB supposed to install into our .env folder. So once it is done here and it's taking through jumps through all the hoops, let's take a look at our env folder and see with side packages. So it installed a whole bunch of other things that it needed to bring over, but it did install our IPDB in here as well. So it is installing it in local environment. Cool. So now we don't have IPDB installed in global environment because not everybody has to be using it, be connected to it, but we do have it installed in local environment. So the next thing that we're going to do, we're actually going to use it. The way we're going to use it, let's go and put at the very beginning, let's just do import IPDB. We can do a new line or we can inline it. So Python does allow for semicolon. If you want to inline it and do multiple lines on the same, multiple code lines on the same line, you can do semicolon and then do IPDB. And then we're going to call command set _ trace. So this command is literally a breakpoint in code and it will execute as such. So we can either go down here and type python modules.py, or we can just hit run. Either one would execute the same way eventually, processing. Let's go. Oh, it will probably go crazy. I should stop it. Yeah, so because it might unload virtual environment and do all kinds of stuff. So let's just go to the command line here and let's explore what's happening. So we're going to type in python modules.py. Okay, so oh boy. Okay, it's jumping through hoops and installing all that stuff through Poetry because I hit that button. Okay, shouldn't have done that. Okay. Okay, let's I'm just going to do a quick reload because I ran it into a corner a little bit. Let's get everything back. Come on. Let's hope our .venv is still there. Okay, .venv is still there. We have our IPDB still installed. We're okay. So the only thing is right now we're not in our virtual environment. As you remember, we need to go source.env bin activate. Let's launch that. Now we're in. Let's do let's just run it. Let's do python modules.py. So we're gonna run it in command line. All right, I'll let you guys catch up in case you got stuck as well. You know, make sure you reload your environment. Your .env should be there. Make sure you type in your source.env bin activate to launch your environment. And now let's run python modules.py. Yeah, sorry for that misnomer. I kind of forgot what was happening within this IDE and how things work. So here we are. So what are we looking at? So we have line Python debugger here that lets us literally walk through our code line by line. And so let's explore a few commands that we have with this. So we have, if you hit question mark, you actually get a list of all the commands that are available in debugger. The annoyance is that there isn't a very good way to circumvent. So if you name a variable u, for example, right, or you name it, you know, qp or something like that, if you try to look up that variable, you're gonna clash with the commands that are available. Just a heads up. So that's a bit annoying there. But what you have here, so just to see the 10 lines around the current current line being executed, right? So what happened was that it executed line 6, which was set trace. As soon as it executed line 6, the next line was the breakpoint. And that's how IPDB ends up working. In code lets you just do the breaking. So it's really cool because if you're in console environment on a server somewhere, you can always take a look at that particular choice and break wherever you want in code and try something in local environment, see how it plays out. So now we have, we can execute our next step, which would be just n, right? Which is kind of a logical one. And so right now, for example, we can type in our variables, right? So we can type in a variable. It says the variable is not defined. If we hit n again, we have executed that line. So if we hit arrow up a couple of times, get the choices and hit enter, we get the output. So the deal is like we can watch and see the values instantly wherever we are by doing that. So let's do hit next line. So now let's take a look at Dunder name. Our Dunder name is main, right? So we'll explore that later once we build a module. And then we're going to hit next. So now we're going through if statement. We are calling the PC move. So we have another capability as we should with the debugger. We can step in, which is S. So you hit S, and that steps you into the function. So it hopped up to the function definition as you would expect it. Go next. You can actually step in here if you wanted to. We're about to do something scary. So we actually stepped into a Python module, right? Because this is all interpreted code. So we actually have an opportunity to look at the guts of that function and see what's happening there and how it works. So we hit next until it basically exits that. We missed out an opportunity. So there's an A. We don't have any parameters here. Let's hit C, just complete it, and I'm going to rerun it again. So the reason I wanted to do that is because you also have an opportunity. Let's see, in PC move, let's do S to step. So I hit N to kind of continue. Then once we got to PC move, let's hit S to step in. And then we're going to, hit S again. And then we're going to hit S again to step into choices. And here we can hit A. And that shows us actual variables that got passed into choice function. So it shows when you hit A once you stepped into the function. If you want just a list of all the arguments that have been passed in, you can hit A and it shows you all the arguments that you have. You can hit C to complete it. You can hit Q to quit. But that's your kind of quick foray into debugger. And that's, this debugger is relatively commonly used. There were unfortunately some projects that I was on where this was one of the few debuggers that was used, just the way the project was kind of modified. There was like a lot of early day hacking that caused it. But this is a way to debug code, and folks use it actually relatively commonly. Not necessarily the way of life, but it's been very useful once you have it in your hands. So that would be on REPL and command line debugging of this. And again, like we have an environment here, right, where we actually cannot debug within the environment because we created the project. So there is some constraint. It happens within some instances within Python where you have this environment. So they put a restriction where you cannot run debugger if it's a project. We have an opportunity to debug regardless. All right, so let's actually wander into creating a separate module. So what we're going to do, we are going to create a separate module that we're going to call game. So all we're going to do is we're going to go here. Let's see, how do we do that? We're going to go to add file on top here, Gonna hit it and sorry, I was in the wrong spot here. Let me close the folders. So let's click somewhere here. Sorry, let's go to modules.py. All right, so let's just click so we can create the module right next to it. So let's hit plus here and create game.py. All right, so we're going to do something rather trivial. So we're going to go create game.py. Then we're going to go to modules.py. We're going to grab the entirety of this code here. So line 6 to line 13. We're going to cut it. We're going to game.py. We're going to paste it, right? So the next thing that we do now, in order to make PC Move available, so if we run it right now, because we are running modules.py, let's go and just run it here in line. So instead of hitting run button, just go to the console and run it on the right. If we run it right now, what just happened, because we copied PC Move out, it says name PC Move is not defined, right? So the logical step for us would be to go to modules.py if we want to call it here, and just go from was it game import PC Move. So what we're doing here a little bit deeper dive. So we don't have to import entirety of the module and then use module name to prepend before each call. We can just say from name of the module import and what we want to import, and that now becomes available within here. So let's go to the right again, hit arrow up, hit enter, and run this. Because we had debugger on, it actually jumped in and stopped us in debugger. Let's hit continue and just run it through, make sure that it all runs. Okay, so what we have done, we have created a separate file, game.py, which is our module, and we have, we do still our import IPDB set trace, we do, random import choices rock paper scissors, and then it imports that whole thing. But what we're doing now in here in modules, because we imported PC Move explicitly, now we have that available, right? So it's kind of, it's all obvious. I'm just kind of chewing it through to show you guys what's where. So an interesting thing to look at, right? So let's, there's another command that we can look at, and that is actually a stack trace. Let's run Python modules again. So if you look at it, we're right now from random import choice, right? So where are we in execution cycle, right? Because we are actually in modules.py, we are at the line 6. We did not declare anything, we did not run anything. So we're at the import time. So there is a command that's called W, it's just letter W, that gives you a stack dump of this, of what Python is doing. So right now we are actually in load time. We're not in execute time yet. So we just called from game import PC Move. So what it started doing is started calling find and load, and just going through exec module and all those Python internals to actually pull out the module and bring it in and make everything happen. So we are really right now at load time. So we're gonna go, our declaring random choice. So it's actually like, you see it executing like you'd execute normally, right? So you're defining function, you're not executing it right now. It's coming out of those frozens. And then it's gonna, after it's going through a couple of stacks, bootstrapping the module. Sorry, I just keep hitting next until we get to something that we recognize. So now we're back at our modules.py, and we're about to call the outer module. And then, so then now if we do s here, right? So pay attention where modules.py. Obviously, if we hit s here, we're going to be jumping to game.py, right? So it's all as expected in kind of our debugging world, but now our module has been loaded and it's showing it correctly. The other thing I wanted to show, we're gonna run this thing again. And the other thing I wanted to show, because we have access to that, let's type in dunder name. So dunder name now is game, right? So what happened is, because we did not run game.py directly, we ran modules.py that then triggered game.py, that loaded game.py. Now module's name is not dunder main, it's game. So if we were to have if dunder name equal dunder main in here inside the game.py, that entry point would get ignored. So this is a cool way to, if you want to have some code that you can execute from command line to test out what's happening in your module, you can have that in your module and you can keep that in your module. If you import that module from somewhere else, it's not going to execute at the load time or ever, right? Because dunder name is no longer dunder main, it's whatever the name of the module is. So that's an important point for kind of your debugging and trying things out. I've definitely used it a number of times for, you make functions that are, I don't know, AWS Lambdas. I've definitely used plenty of times there, because that would be the path that AWS Lambda would never execute when it runs in the environment, but I can run command lines locally to test all my code calls. So the next thing we're going to look at, the next and final layer within this exercise, is not just making modules, but making packages. And so let's make a package called games. So the way you would make a package, it used to be in Python 2's permutations, which is no longer viable or meaningful, but in older times you had a notion of a package that is formed this way. So what we're gonna do, we're gonna go to add a folder. Let's name that folder games, just for clarity. And so within that folder, what you would do, you would add a file that is going to be called dunder init.py. So that specific file, it is still absolutely viable. It is still absolutely understood by Python. That specific file is a file that is going to get executed before a module is loaded. So if you want to do any kind of exercises before module gets imported, this code gets executed at the load time for the package. And you don't have to call it explicitly. By convention, it will get executed. And so, however, in original Python, if you didn't have anything to say in dunder init.py, if you wanted to have a package, you still had to have the dunder init.py in the folder, and this is the only way Python would treat it as a package. Nowadays, that's no longer the case. That's no longer the requirement. That being said, however, various frameworks are still leveraging that to search paths. So like testing frameworks like PyTest that we're going to be using in the next session does leverage that. And so it leverages that for its own tests. And so it is useful to have dunder inits in the folders, subfolders of tests, for example, so that it can find its way up to the highest layer, and so it knows what's outside of its own packages and things like that. So dunder init.py is still a decent convention to do for your packages. Anyway, so we have games folder, dunder init.py goes in there. So what we're gonna do, we're gonna grab game.py and we're gonna drop it in here. So we have game.py, right? Dunder init still remains empty. We're just gonna keep it like that for now. So we have this call here. Let's comment out the IPDB trace. So if we run this, if we run our modules.py right now, we're gonna get that error again, because what happened, no modules named game is available, because what happens is that the path for that module is no longer true. So the way we would modify the path in our modules.py, we would go and say games dot game blah blah blah. So what happens here when you define that package, you then, this is your Python path as it is expressed internal to your code, is you have your your Python path, all those folders that it's going to be looking for modules in, and then from that point on you say, hey, once you look in that folder, within any one of those folders you're going to find a folder named games that is going to have a Python file named game, and you're going to import module from it. So now if we go to the right and we run this again, everything came back together and worked, right? And so everything else from that point kind of comes together and does what it does. One of the things we could do is let's do this. Let's go into underneath.py and let's do print running games dot underneath. So we're gonna put that in here, and then we're going to go in the beginning, right? So we're dealing with load time here. So at the line 4 we're gonna print loading games.py, and then we're gonna go into modules and we're gonna do print start games import, and then print stop games import. All right, so we got all that in place. So again, so what we did here, we went into the underneath, we put running games underneath, we went into games.py and set loading games with an m.py, and then we go into modules, I'm losing it, modules.py, and then we're going to start games import and stop games import. All right, so let's go into the right line and we're gonna run it. And so as I mentioned, so we start games import, it is gonna run games.underneath, loading games.py, stop games import, PC move was scissors. Yeah, so it's really cool because the deal is you can do various system initializations before your package runs. You can do various kind of magical things where by the time package is used, everything gets like executed and aligned and elevated and ready to go, and you have this kind of global factors or whatever that you can run against to pull everything you need. Yeah, it's kind of a common pattern. It's quite an important pattern to understand. I've definitely seen libraries that have their entirety of their definition in underneath.py, which is kind of wild, but it's an interesting convention to be aware of. So I would really like to, we've created a separate module, we've created a separate package. I think this is kind of a nice boundary for this lesson. And hopefully that gives you all the necessary information to then understand the world of modules and how they come together and how the virtual environments come together for you, and how in the world you do debugging with IPDB. Again, the notes are attached for this particular lesson because, as you see, we've jumped around quite a bit and touched on a lot of points. We weren't just stuck in the Python, an individual Python file. So I would close on that one, and thank you for coming again and for watching the stream, and I will see you next time. Have a good one.